Hello everyone. Welcome to Øyvind Lervik Nilsen's presentation about how do fixed links affect residential and firm location. Just for your information, this session will be recorded. Your names will not be visible if you don't ask questions though. So Øyvind, please go ahead.
Thank you, Katrine. Good morning, everyone, and thank you for attending this Skype presentation. I will now go through some slides regarding how do fixed links affect residential and firm location, some empirical evidence from Norway. This work is part of my PhD. I'm currently in my third year and I have 1 year left. So part of these slides are ongoing research, meaning that they are not published yet, but some of the parts of the presentation are published work. My PhD, I am in a group of 4 people, and my supervisor is on the left side. Her name is Trude Tørseth. And do you see my arrow? Katrine, do you see my arrow? Yes, thank you. Yeah. And the other group is Stig here, and this is Maria, and this is me. And we are doing research within the same topic, but a bit of different directions. This teamwork has been, I have to say, both motivating and very helpful ensuring our progress in the PhD. So back to the contents of this presentation, I will first start by an example just to show you how a fixed link can change the labor and housing market and what do I mean by that. I will then go on to the literature and look at how the land use transport interaction is. The land use here, I mean what's on the for instance, an island that connected, that could be the population and the number of firms, etc., and how a transport investment like a fixed link might affect that. I will then go on to look at different aspects of why that is important in terms of the assessment tools we have in Norway today. Based on this, I will form 3 research questions, which then will be tried to answer in the next 2 points, which are written here is what has happened and which factors are behind these changes in these fixed links. And in the end, I will try to draw some conclusions. Okay. This is a typical example of a fixed link. Here you see Rennesøy and Finnøy outside Stavanger on the left side. In 1992, they were both connected by ferries. The total travel time to Stavanger from Rennesøy was 2.5 hours, and from Finnøy it was 3 hours. And then you got in 1992 a fixed link to Rennesøy, which dramatically reduced the travel time to approximately 25 minutes. Still, Finnøy was connected by ferry, and in 2009 they also got connected by a fixed link. And as you can see, the travel time reductions are substantial, and they are both now within commuting distance, you might say, to Stavanger. So they are within the same labor market, and also within the same housing market. We actually talked to some people on Finnøy, and they were able to move back to Finnøy now because they could keep their jobs in Stavanger and still live at Finnøy where they were born. And this is a typical example. And of course, when you have this dramatic change in travel time to Stavanger, there will be some changes on Rennesøy and Finnøy. I will then go on to the next slide. This is a typical wheel of how the transport investment like a fixed link will affect the residential location pattern and the firm location pattern. On the top you have the transport system today, and then you build a new link to for instance, Rennesøy or Finnøy. And then you get increased traffic demand to these islands, like more trips to this island, and maybe a change in destination. More trips from Stavanger chooses to go to Stavanger, Rennesøy and Finnøy than before, etc., etc. But you will also get a change in accessibility. By accessibility, I mean the number of possible activities that you are able to attend if you live in Finnøy or Rennesøy within an acceptable travel time. For instance, you might live at Rennesøy and be able to go to soccer practice in Stavanger, etc., etc. And all these things, they are important when people choose where to live, and also where firms chooses to locate. Because when you have these changes in accessibility, you also have a larger labor market. It's easier to recruit the right people, and you could also have easier cooperation with firms on both from that were earlier on Rennesøy. You can now easier cooperate, for instance, with firms in Stavanger, etc. So these things actually do affect where firms and people chooses to locate, and this in turn changes the land use on this island, which again have an effect on where people live. And this again, of course, affect the data that is used to calculate the traffic demand, because now you have more people on the island than before, which give more trips, etc., etc. And you might expect that these changes are larger when you have a larger change in travel time. For instance, if the travel time reductions from the island to the mainland is larger, you are more likely to have a larger change in all these things. And also, if you have, if there are more people living on the mainland, and there's more people or jobs connected, you will also have a larger change in these things. And why is this important? In today's assessment tools, we do not take these kind of changes into account. Usually we focus on what's on the left side here. We calculate the travel time reductions and the changes in travel destination choice and mode choice, etc. And then we calculate the user benefits for those people using that bridge. And in most cases that's totally fine, and you are able to capture all the benefits that are associated with the transport investment. But in some cases where there are a large change in large travel time reductions, you will get these effects on the right side. And they are associated, might some argue, there are some benefits associated with some of these. In this presentation, I will focus on what's inside the green circle here, which is changes in the residential location pattern and then the firm location pattern. And it's essential to know if the transport investment actually changes these factors, because then you could look if there are some possible benefits with them. So, but in this presentation, I will focus on if a transport investment affects the residential and firm location pattern. Another reason why this is important is that people are very see these transport investments as tools to promote economic growth and to make areas more attractive for residential location and firm location. And very often they are the reasons that the projects are put forward is expectations for economic growth and that these areas get more attractive. But in the end, the tools that you are using to actually assess the transport investment, in the end, do not take that into account, which in some cases could be a bit problematic. And another reason that this is important is that this ferry-free E39 project will dramatically change the accessibility for many areas along the route, linking working region, housing markets, etc., etc., which are likely to or at least could change the firm and location pattern along the route. Therefore, it's essential to get more knowledge on these effects. Okay, so the first question that we asked us was, what had happened? Do we find the same changes that we have seen in the literature on actual projects? And based on these projects, could we make some kind of models to predict if there will be changes in land use for future fixed link projects? So the first part was what have happened, and then we tried to model the relationship between transport investments and firm relocation. And also trying to model the relationship between transport investments and the housing market, which is, the housing market is usually the first signs of increased attractiveness for residential locations. Areas that get an increase in housing prices are often areas that more people are willing to or want to move to, and it's an occasion of residential growth, population growth. Okay, so the first question, what has happened? We looked at 11 cases on the western coast of Norway. For each of these cases, we looked at different characteristics. That could be the distance to the nearest city, the average housing price in that island, or it could be the number of employees, and many different variables that were found relevant in the literature. We tested these on these islands. We focused mainly on the connected island, and then we tried to see what was the effect of the fixed link. Of course, that is not that easy, because you want to model what would have happened if you didn't get the fixed link. So we compared the growth after the fixed links was built to a similar area that did not get the fixed link, and that area was used as a control group, and the difference in growth between those two gave us a value indicating the extra growth that was from the fixed link. And then we saw that on the different variables we looked at, we saw that for all of the cases you had an immediate traffic growth. So that was kind of an immediate effect on the fixed link. And you then had an extra growth again in traffic when you get the toll removal, because most of these fixed links, they have a toll on them. And then you had, for some cases, you had a population growth, while for others you didn't have the same kind of growth. So even though most of the cases experienced a population growth, it was not a clear trend regarding the size of it, but it varied between cases. And it was also the case for housing prices, where you, for most cases, had a growth, but it varied a bit. And we also got an increase in the number of firms, employees, and increased commuting between the areas that got connected and the mainland. We did a survey just on the firms that were on this island, and just to get some more knowledge behind these numbers. And most of these firms had hired more people than before from the mainland, and they also had more cooperation with the mainland, but they also had increased competition with firms on the mainland. So we had many different aspects, and this fixed link had an effect on the firms in different ways. This is the population growth. For the areas that are close to larger cities, you see a growth, and it lasts for some time. The changes in the moving of people is a process that usually takes some time, and it will continue probably for more years than these 20 years. But at least it gives us some kind of indication of that these areas got an increase in population compared to some areas that do not have that big a cities close to them. Most of the people that were moving to these islands that has the largest growth were moving from areas on the mainland. So they could, for instance, move to Rennesøy and keep the job in the city, etc., etc. Okay, so the last two research questions is related to trying to empirically model these different changes that was found in the population and the firm relocation, the firm growth. So, of course, transport investment is probably an important part, but there is a lot of other aspects as well which are important. So, in order to get some help regarding how to approach this problem, there are some literature on land use transport interaction models, which exactly model the relationship between transport and land use. What you do, you take the fixed link and put it into a transport model, and then you calculate the change in accessibility, meaning the number of possible activities that you can reach before and after the transport investment. And based on the changes in these accessibility and agglomeration, you could calculate the changes in housing prices, which is an indication of the attractiveness for residential location and then for firm relocation. And you could also, in the end, model how people move, but we haven't got that far. That's the gray box there. And when you have done all this, you get a new set of population data and firm data, which again could be put back into the transport model, and you will get a new transport demand. There are some of these Luti models in Europe, in UK, and has been quite much used in the US, but it's mainly been used for cities. The new thing here is that we try to use it for these fixed link projects, because you have many of the same issues, because you could expect a change in land use from a transport investment. The thing is that I go to the research question 2 regarding firm relocation. There are some literature showing that when you get an increase in the number of jobs within an area, also called employment density, there will be some benefits from it called agglomeration benefits, and firms will try to move to areas that have high employment density. And when you build a new road, for instance, you have more jobs that are within the same travel time, so you in a way increase the employment density and reinforce these agglomeration benefits. The agglomeration benefits could be, for instance, that you have more potential customers close to your office, you have more office that works with similar things that you could share knowledge with, and you also have easier to recruit the right people for the job. But we wanted to check because when you, for instance, if you build a new road to an island, the island will be connected to the mainland, and therefore the number of employees that are within an acceptable distance will increase. So in order to try to model the growth of firms on these islands, we tried to make a model to find a relationship between this employment density and the transport and firm relocation. So we started by taking data from the Brønnøysund register and looked at the firms that did move. It was approximately 16,500 firms. And then that was the total number of firms that was in that time period on the western coast of Norway. Of these 16,500 firms, it was approximately 2,500 that did move in the period. And then we tried to look at different characteristics of those firms that did move and try to find some model that could help us model if a firm chooses to move or not. In the literature, it's often logic models that are proposed to deal with these issues. We try to do that also here. And there are, of course, this employment density is not the only variable that's important. There's a lot of other stuff as well. We included some internal characteristics of the firm and changes in that, and also these external factors that might be affected by a transport investment. That could be, for instance, the number of jobs within a certain travel time, the number of people within a certain travel time, and also the moving distance, the distance of firms chooses to move is quite short. So areas further away have a low probability of being chosen, while areas close to the firm have a higher probability. And based on these factors, we estimated some models that calculated this relationship between this transport investment and the employment density and this population density and this moving distance, etc., to see the effect that the transport investment could have on the probability of attracting firms. We used 80% of the data to estimate the model, and we tested that model on the rest of the data, the 20% of the data, and we were able to predict around 75% of the choices made by the firms. And what we see is that these firms, they move relatively seldom. 1-2% each do move each year, and when they do move, they often move short distances, mainly because they want to keep their employees, they want to keep their customers, and it's often related to different needs in office space, for instance. We did see that these firms, when they do move, they are drawn towards areas with high population and employment density. So when, for instance, a fixed link is connected to an area on the mainland, which is a larger city, that it will be it could be an attractive area for firms because you have short distances to many people and employees. But we saw also that they were drawn away from areas that had high land prices. And there are, of course, differences between sectors. Business services was the most mobile. They could move further distances and did move more often, while manufacturing, for instance, did not. And this means that if you have an island and you get it connected, and since these firms move relatively short distances, growth in firms on the island are most likely to be, or often are, firms that move from the city to this island. Yeah. Okay, so that was the firm relocation model. This next part is the housing relocation model. The aim of this model was to look at the relationship between housing prices and transport investments. As I mentioned earlier, an increase in housing prices are usually the first signs of increased attractiveness for residential location. And this relationship between transport investment and housing prices has been modeled several times in the literature, often through regression modeling. However, it's not that often used on fixed link projects. So it's a need for doing that exercise in order to get some idea of the growth on these islands. And in order to develop these models, we used approximately 8,000 housing transactions in 2 counties, one in Rogaland and Møre og Romsdal. We made one model for each county. And then we made that model, we tested on 2010 data, where Eiksund, Samband and Finne was built. And again, of course, this transport investment is one part of many things that goes into what determines the housing price of a house. But the transport investment do affect some of them. The accessibility measure, for instance, which is the number of possible activities that you can reach within a certain time. And also these 2 next one, which is the travel time to the sub-center and then to the regional center. The models were able to predict the housing prices. 70 to 75% of the predicting house prices had an error below 30%. I think 20% of the predicted housing prices had an error below 5% in 2007 data. And when you use that model to estimate the housing prices in 2010, around 60% of the predicting housing prices had an error below 30%. It's a bit challenging to use such big models because we've developed models for the whole county to use them on small areas within that county. So we saw that the model did perform the best in the cities, while in the more rural areas it didn't perform that well. So it might be further developed to try to deal with that. But we saw that it was this transport investment had a positive effect on the attractiveness for residential location or the housing prices. The distance to the main regional center seems to be the most important. Well, distance to smaller towns and sub-centers are not that important. Yeah, and the degree of housing price, change in housing price, do depend on how big the cities you get connected to, and the degree of change in travel time. Okay, so that was the 3 different research questions. As you can see, the fixed links, they might change the housing market, labor market, and also affect the location pattern for firms and population. And to which degree that varies, and it seems to be area and project specific. The travel time reductions and what's on the mainland is important factors regarding how big the change is. Using this LUTI framework to try to get some indication of how big the change is from a change in travel time from a transport investments seems to give some promising results. We are yet to test these models on other projects to see if they work, and there's also some research left on developing this relocation model for residential for people. This work, as I said, has been published, some of it, and some it's ongoing. Here it's the different papers that you can look at it more in depth if you want to. These ones that are under review, I can send you if it's interesting, and also these ones that are not sent to journal yet. Okay, that was the presentation. Thank you. Any questions?
Yeah, thank you, Øyvind. Nice presentation. We can now go ahead with questions. You can either ask your questions or you can write them down and I will read them for Øyvind. Yes.
Okay.
I have one question. The models that you're working on, you said they did not work so well with the rural areas.
Yeah.
Do you have any idea on how to improve the models?
Yeah, actually, I think you could add some controlling variables for that in these models that probably will improve it. So that will be that's something we're working on now, and that will probably improve these housing relocation model. Yeah.
Okay, thank you.
Any more questions? I have a question, though.
Yeah.
Yeah. You talked about a reduction in travel time. So I wondered, do you have any sort of time frame for when the result kind of like the discussion about the 1 hour, also reduction to 1 hour or more than 1 hour? You said the results depended on the travel time. So, yeah, do you have anything? Do you see anything?
Yeah, these models they say that the possibility the chance of an island attracting firms and population decreases with the distance, the travel time, or general travel cost, which is used in these calculations, but it's simplified to travel time. They get reduced when you get further away. And I don't have a like 60 minutes, but exactly 60 minutes, but we follow a curve going down that after such a long time it will not attract that many people anymore. But that's possible to add to that model to see when it doesn't attract any more people. You could do that or by just putting in numbers in that regression model, for instance. Then you will get some indication on when it's not when you cannot expect a growth in housing prices, for instance. If you are 60 minutes away from the Stavanger, you will get such a big increase in house prices, while if you're 90% away, you will get that smaller increase, and you can put those numbers into the model and get some indication on the change in housing prices and also the number of firms that you will attract.
Okay.
If you understand. Yeah.
Yeah. Thank you. Does anybody else have questions?
Yeah, could I have one more? You said that the relocation of firms or companies was quite small, 1 to 2%, if I remember.
Yeah, that's correct. Each year.
Each year. Is that the total for Norway or that location?
No, that was for the western coast of Norway. So that was Rogaland, Møre og Romsdal, Sogn og Fjordane, and Hordaland. And for that data set, we saw that 1 to 2% choose to move each year. We checked that number to other research done elsewhere in Europe, and it seemed to correspond pretty well. It was around 1 to 2% of the firms that chose to move each year. Yeah.
Okay, because I was thinking that if that was on the west coast, it might be easier to relocate if you are in a more central part of the country, but it might be the same.
Yeah, at least when we checked it to data from Netherlands, because that's the country where they had done the most research within this, and they had the same percentage at least.
Okay.
Yeah.
Yeah.
Okay, I have a last question.
Yeah.
You were talking about the firms moving, but what about new establishments?
Yeah, that's a good point. That I haven't looked at yet. And there are some that argue that when you get areas that have high employment density, that you will easier get new firms establishment. But that part I have not looked at.
Okay, so it's not included in this
No.
study?
No.
Yeah. Okay. Yes. Yeah, okay. Thank you again for your presentation, Øyvind. It was really nice.
Thank you.
The next presentation in Society will be after the summer. It will be on September the 7th at 10 o'clock. Thank you all for attending.